Hey, so here's our next project we're going to do. We're going to do this in integrated 3 and also in pre-calculus. So you're going to figure out whatever you want to write. It could be your name. It could be a design. It could be a piece that goes into a pendant. So it can be made out of geometric shapes. This is one idea I have. We're going to take the best product in the whole class, and we're going to vote on whichever one comes out the best. And then we're going to put it on our tree transformation store and see how it sells. So there's a little bit of a competitive element. We're going to integrate the math and the making together and the entrepreneurship. So you could engrave it like that if you want, engrave and cut it out. This case right here, I just took that same thing and just cut it out all together. Or you could take the positives of this and just glue them like that. Take that Desmos series of equations and graphic, export it in a Corel Draw, and then we're going to vectorize that and either laser cut it, laser engrave, or CNC cut it. There's my graphic, and then in Desmos, I created all the equations to represent that graphic. So you're going to turn in your graphic, all of your equations, and your project. It could be, like a pendant around your neck like that using shapes, a set of earrings. I have both the strings for necklaces or the things for earrings as well. We're going to vote on the best one. The best one's going to go on our store. So there are 3 components: the math, the making, and then the entrepreneurship of it. So I'll just do a couple letters here. So now I'm going to hit enter. I want to do tangent. So I'm going to do that as a vertical line. So x equals, I think I want it to go right here at 22.5. So 22.5. And then curly Q brackets for values of y between 0 and 6, 7, 8. So for values of y between 0 and 8, close curly Q. So there's my tan. And then I'm going to do a horizontal line here. So that's going to be x equals 8. I'm actually just going to copy all that, Control C, enter, paste. So there it is in Corel Draw. Hit File, Print, VLS 3.6, Settings, Thickness with the calipers, and then now it's running. See, it's engraving right there. There's one of the little Sokotoa keychains on the graph. It'll do all the engraves first before it does any cutouts. Is that the end of the letter? Yeah, then hit orange to retract. Move it, keep it down on the board, but move it over a little bit. Just so I can see what we have.
Start again?
Yeah, you on the next letter?
Yeah.
Yeah, so you have to go down to like a starting point on the next letter. Where the bottom one was? Yeah, so right there. And then hit start again. And then, yep. Sam, come over here and give this thing a try.
Okay.
So we're on the Sokotoa part. You want to bring it all the way. Put both your hands on there, and then bring it to the right, and you'll see the T. Yep. So you want to keep moving, and then see how the T just go up a little bit. There you go. And then if you're ready to cut, you're going to hit cut with that right thumb over there, and then follow it where it tells you to cut. You could actually go fast. And then now you're pulling it down towards yourself. You're starting to lose the circle. So move it to your left. I think we're all done. So go ahead and turn the router off. There's the power button right there. Let's take a look. Dun, dun. Sokotoa. There's some cuts in there before. But man, that's cool. Oh, that's super cool. All right, here we are in pre-calc. This has been a fun project. The students just finishing up a section in trig. They did a project on a big learning thing they took away from trigonometry. Here's the first presentation. Go ahead.
Okay, so me and my buddy, can we use names? I don't know. We made a pie wheel. I like to call it a pie wheel, and we did phases of a unit circle, except we did it in kind of phases of the moon. And actually, the shading of the moon aligns with the degrees that go around this unit circle. And the only struggle with trying to make this was trying to find the right shading for the moon that matched the degrees, so we had to have some help.
We just use in Desmos, we use different equations for our circles and manipulate them to different sizes to create the outside.
What are you doing?
Taking the screw out.
All right, what do you got going here?
A belt buckle.
What's it mean?
I am number one.
Oh, trig identity.
Yeah.
Cosine squared plus sine squared. And you made it a belt buckle with the universal laser. Very good.
Yeah.
Pull it out of there. Let's see what we got. Tell us about it.
It's a record. I like Elvis and I like music. Okay, this is cool. So as it goes inwards, the linear velocity decreases. So there's this theory that because of that, there's less room but the same amount of information. So the sound quality is worse when it goes inwards because there's not as much information and area for it.
There we go. Angular linear velocity. Beautiful. All right, here's a cool project. What you got going here?
I got a clinometer, which we laser engraved kind of like directions on the front, cut out a nice little pocket for it with the CNC, and then laser engraved the numbers on the clinometer.
Oh, beautiful. What's a clinometer for?
It's for measuring like angles you can't reach, or like how tall something is from a distance. You take the angle and then use the law of cosines and calculate the height of a tree or whatever else you're trying to calculate.
Beautiful. Oh, I love it. I love the book.
So basically what this is it shows how the unit circle can be related to a table saw blade spinning, because at any point given on this tooth, the relationship of this side of the triangle, which can be created from the table saw blade, is increasing and decreasing like a sine graph. So a table saw blade can be modeled with a sine graph.
Here's a cool project. What do you got going here?
I basically took two linear lines and I cut them off, and then I took a parabola but I stretched it out so it made it more curved at the bottom, and I did the same up here by using domain and range so then it doesn't like exceed. And then I did a bunch of little circles, and these have dash marks on them because they're inequalities and not full circles.
Oh, beautiful. Pepperonis.
Yeah.
What do you got going on yours?
I used linear functions and ellipses functions to be able to create a spider web on Desmos, and then I used a laser cutter to print it.
Cool. Oh, this is cool. What do you got going here?
It's just a lizard drinking out of a cup made out of parabolas and circles and ellipses and linear equations.
Cool. So those are all the equations and another page of them. And then all those equations are that image in Desmos, exported to CorelDRAW, run on the universal laser. Beautiful. Oh, that's a cool project. So designed in Desmos, pages of equations. Tell us about it.
It's a necklace. It's just some triangles.
Cool. Here's a cool project right here. This is in CorelDRAW after created in Desmos. Cubic functions, circles, linear functions. Here's a cool one right here. This is, what's this thing called? Paralligator. Drawn in Desmos, laser engraved on the universal. Beautiful. All right, what do we got here?
Coco, the dog.
Oh, beautiful keychain, drawn in Desmos, imported into Corel, and now going to get laser engraved into a dog keychain.
Yes.